Alright, so here we are with the 5-5 assignment solutions. So we're going to just go through and use some trig, in fact the law of sines to solve. On our formula sheet we do have these guys right here. I also took the time to write down our special case, that idea of if there are two triangles to solve, it's because the adjacent side to the angle given is greater than the opposite side to the angle given, versus if it's less than, then it's just one triangle. So we've got our law of sines that sets up our proportions. So for instance, A over A, but it turns out we don't have a distance of A. We've also got angle B over side B, which we do have an angle of, so that would mean that sine of 45 is going to be in proportion with 3.7 when we solve all of these. And then the last one is angle C and side C, which we don't have much of. So that proportion is going to be set up with sine of the A angle, which is 60, and then we can use it to find the A side length. So to solve, we're going to cross multiply, so we're going to have sine of 60 times 3.7, of course in degree mode because we are putting in 60 degrees, and then that's going to be equal to A times the sine of 45, which of course without getting the actual decimal values we would divide by sine to both sides and get our A value. So if I type in sine of 60, double check I'm in degree mode, sine of 60 times 3.7, and then that value divided by sine of 45 means that our A value is 4.53. So our A value is 4.53, that's one of the pieces we're trying to solve. The next one we're trying to find the C value, so we can get your C angle by the fact that it's 180 minus 60 minus 45. And so we have 75 for our angle of C. And then to find our side length C, we're going to set up the same proportion as we did before, only now it's sine of 45 over 3.7, and then that's going to be equal to sine of the C value now, so 75 C angle over C. Cross multiply and divide, so technically you could just cross multiply those two pieces and divide by sine of 45. So I'm going to find sine of 75 times 3.7, and then divide that value by sine of 45, and we get 5.05. So remember, when it says solve, that means that you're just finding all of the missing pieces. So in this next one, that's angle B, side C, and side B. So I'll show the setup for what I'm doing here. So in the next one, the two pieces that are actually given are angle A and side A. So both of my proportions are going to have sine of 100 over 22 when I solve. And in order to find side C, for instance, I'm going to have it set equal to sine of 35 over B. Oh, sorry, that's a C. And then in the last one there, angle B and side B means that I need sine of an angle I got to get over side B. So how do I get the angle of B? I do 180 minus 35 minus 100, and we get 45 degrees. Alright. So then we're going to plug in the 45 here so that we can solve. And again, cross multiply, divide by the sine of 100, cross multiply, divide by the sine of 100. And our C value comes from sine of 35 times 22 divided by sine of 100. And so that's our C value of 12.81. And then our B value comes from sine of 45 times 22 divided by sine of 100. And so that's 15.80, because 796 rounds up to 80. Alright. So then our next piece here, we're going to solve the triangle. Since there's only two angles and a side length, our ambiguous case doesn't come up. If we look forward, it might come up in this one, and this one, this one, and this one, because they have one angle and two side lengths. This one also might be there. Again, one angle, two side lengths. This one here is telling us that it happens, so we already know that's going to be there. And this one is not asking that, so anyway, we'll just want to make sure we're aware of it. So that means that as we're looking at this one here, we are trying to find angle C. We need side A, side B, oh we already have side B, angle C and side C. So to start out, our one proportion is going to be B, so we're going to use sine of B, which is 30, over 10 in both of our proportions that we're solving. And then with the A value there, we're going to use 40, so sine of 40 in order to get our A. That was supposed to be in blue. And then in order to get our C value, to get the angle measure of C, we need 180 minus the two angles that are given, so 110. And that's going to be over our C measurement. So cross multiply and divide, cross multiply the two values and divide, means that we're going to get sine of 40 times 10, but then divided by sine of 30. And so for side A, we're going to get 12.86. And then for side C, we're going to get sine of 110 times 10 divided by sine of 30. So 18.79. Alright. And then they give us the same setup in the next one, so we're going to do the same solving. So we've got A side that we need, angle C, and the C length. This time we're going to set up with sine of 70 for our B angle over 7 for our B measurement length. And then to find our A length, we're going to do sine of 33 over A, don't know what it is. And then again to find C, we're going to do 180 minus the two angle measures we already have, 33 and 70. And so that's 77 degrees. So that means that we're going to do sine of 77 over our C value that we don't know. So again, cross multiply the two numbers, divide by your other number value, and it will equal your letter value in your proportion solving. So sine of 73 times 7, but then divide all of that by sine of 70, and we get 4.06 for the measurement of A. Measurement of C comes from sine of 77 times 7, but then that divided by sine of 70 gets 0.26. Alright, and of course you could draw a picture to kind of see which things are opposite, but it's always going to be a proportion of the two pieces that match, so B and B in this case, and then finding the other pieces in a setup. So let's see, this next one here, this is one that could be an ambiguous case, but I'm doubting that it is. Remember that we're looking for if there's two answers. The two answers are going to be where the adjacent side, the one attached to the angle, is greater than the opposite side. So the adjacent side is greater than the opposite side. Alright, so if I drew this, my angle at A is 32, my opposite side length is 17, and B is 11. So let's see. B is 11. The adjacent side is not greater than the opposite side, so this is just one case. Alright, so let's set up what we have. These two pieces are given, so those are going to be the part of the proportion that is in both problem pieces. And then that's going to be set equal to the fact that we don't know what B is, but we're going to work backwards and get it. I can't do the next piece because I don't have two angle measures, so I'm going to have to wait until I get the measurement of angle C in order to plug it in here in order to find C. So let's see, I'm going to cross multiply and divide in order to get my missing pieces, which are, I kind of wrote big, but are side C, angle C, and angle B. So in order to get angle B, we need to do is, oh, I can't do those ones. Sorry, just wrote over that. Have to multiply these two, which are numbers, and divide by 17. Alright, so anyway, we need C, angle C, and angle B. So in order to find sine of B, I multiply sine of 32 times 11 divided by 17, and that gets you 0.3428, but it's an 8/8, so anyway. And so in order to solve, I need to take the sine inverse of both sides to get B all by itself. And so sine inverse of that decimal leaves you with a B angle of 20.05. So now that we know that B is 20.05, we can end up subtracting from 180 in order to get our angle measure. So we can do 180 minus the angle we knew to begin with, which was 32, minus the angle we just found, which is 20.05. And so we have 127.95 for our measure of angle C. Alright, so I'm going to put in 127.95, and now I'm going to cross multiply and divide by sine of 32 in order to get the length of side C. So sine of 127.95, and depending how much of the decimal you abbreviated, which in this case I apparently abbreviated 2 decimal places, which is not fun, I just don't want to go back and get the rest of them, means that I'm going to have probably a slightly different answer divided by sine of 32 than maybe what the book has. But alright, so the side length of C is going to be 25.29, which is 0.30 because of the rounding. Alright, so that's number 9. Number 11, I'll try to write a little bit smaller to give myself some room, but we are going to use sine of B and length B in both of the proportions. Oops. And at least in the first piece, that's going to be set equal to sine of angle C, which we don't know, over 9. And so I'm going to be finding length A, angle A, and angle C. So to solve, I cross multiply and divide by sine of 70. Oops, I did it again. Gotta cross multiply this piece that actually has numbers and divide by 14. So sine of 70 times 9 divided by 14. So that means that sine of C is equal to 0.60408, so 1. And then I need to take the sine inverse in order to get C all by itself. So sine inverse of the decimal that we got means that angle C is 37.16 degrees. Which means that if we want to find angle A comes from 180 minus 70 minus 37.16. So angle A is going to be 72.84. Which means that when I set up my proportion, I'm going to do sine of 70 over 14, but then that's going to be set equal to sine of our new degree measure, 72.84, over our missing side length of A. So we cross multiply, divide, meaning sine of 72.84 is going to be multiplied by 14, and then divided by sine of 70. So our A value is 14.24. All right, let's see. I didn't necessarily check that one to see if there were two solutions. Let's go back. We've got 70 and 14. Yep, the adjacent side, which is this, is less than, so it's not the ambiguous case. Okay. So let's try these two just to double check if this is angle A and this is side A and this is side B. Potentially that could... Alright, so anyway, I drew the triangles of both of these, so these are both in that ambiguous case, so very interesting. Alright, so that means that I'm going to need to, let's see, I have a sine to set up, so sine of 36 over 2 is going to be one of the proportions, and then I'm going to use that to find sine of, well, the actual angle of B, and then 7. And then once I find that angle B, that's where I end up making the second case. So let's go ahead and find angle B. So angle B is going to come from taking sine of 36, multiplying it, dividing by 2, and then taking the sine inverse of that. So we're going to do sine of 36 times 7 divided by 2, and then that decimal I'm going to take the sine inverse of. Which does not exist, and so this ambiguous case can't work because of the letter. Alright, we're going to back up because apparently I forgot the directions for this one. This one says that we should be stating whether the given measurements determine 0, 1, or 2 triangles. So, yikes. Okay, so I would have said 2 for this one, just as I did for 15, but then when you actually go through and solve, you realize that you can't take a sine inverse of a value that's over 1, and so in that case this is no triangles. Interesting, okay. So then we'll just double check with the next one to make sure that it is possible as well. Otherwise, the idea is that the image has a 36 degree here. The opposite side is 16. The other angle of A makes this the opposite side of 17. And if I put A over here, it actually would have done the same thing because it's adjacent no matter what. And so because this side is longer than this side, that means that we get that ambiguous case. However, we need to double check like we did in the previous one to see if it actually will solve. So we're looking for sine of 36 over 16 equals sine of the A angle. And so we need to cross multiply, as I just said, divide by sine, but then take the sine inverse. of A, sine inverse of the sine of A, which is what we would get. And so if we take the sine inverse, that means that angle A is going to be sine of 36, times 17 divided by 16, sine inverse, and that works. Well, that's an 8. And so because that works, we can continue, and we'll end up with 2 solutions. So basically the idea is identify if that adjacent side is bigger than the opposite side, and if it is, then you need to test to see if the case actually exists, so if a triangle is there. Otherwise, you can continue, hopefully once you get an angle of that first measurement, so that you can substitute that in and get its supplement in order to do the other triangle. Alright, so apparently I missed some directions on that. So here are the directions for this. It was supposed to be 13 through 18, and we ended up having 13 through 15 up here. Anyway, so the next one is the same idea. We're going to have a triangle at 30 degrees here, have its opposite side of 9, adjacent side of 18. And so because of that adjacent side being larger than this opposite side, we're going to end up having maybe 2 cases or maybe none. So we have to double check that the sine of 30 over 9 can actually be solved with the sine of the A angle over 18. So if we check to see if that works, we're going to do sine of 30 times 18, and then times 80 divided by 9. And then that's actually 1, and so that's going to be 0, which is not possible. Sine inverse. Oh, that's actually 90 degrees. Oh, so it's a right triangle. Fun! Okay, so angle A is 90 degrees. Sorry, I was thinking it was going to be 0. And because we're doing sine of 1, I just kind of assumed that was at 0 for some reason. Alright. So that means there are 2 triangles possible because you were able to find that missing angle A in order to then get its supplement. But supplement to 90 is just 90 again? Huh. So it's not 2 triangles. Wow. Just 1. Okay, because we'd have 2 triangles that are the same, because supplement to 90 is 90, meaning same triangle. Right triangles with the sine is not really important because you could have just used trig, so basic trig instead of a trig formula. Alright, so that was fun, super. So the next one, 2 triangles can be formed, so we know that this is happening, and so we're going to solve both triangles using our idea of getting that second triangle. So, first piece is our proportion, which is sine of 64 over 16. And then that is going to be set equal to sine of the B angle that we don't know over 17. And so in order to solve for angle B, we're going to end up getting sine of 64 times 17 divided by 16. So sine of 64 times 17 divided by 16, but then the sine inverse of that, which gives you a 72.74 degree measure for angle B. But then the alternate angle B is going to be 180 minus 72.74. And so that means here angle B, the next one, is going to equal, that's how you make subtraction, right? Okay. 180, 72.74 is 107.26. And so now we split into 2 categories here, where one of them we could continue this original one to find angle C. So angle C is going to be 180 minus 64 minus 72.74. So 43.26. And then we can use that original proportion of sine of 64 with our new sine of 43 in order to find side C. And so sine of 43.27 is going to be multiplied by 16 and divided by sine of 64. And so that's a C of 12.20. And so our answers for this one are, let's see, the one case with an angle B of 72.74, a side C, an angle C, sorry, of 43.27, and a side C of 12.20. And then the other case now gets us to angle C, a new angle C, being 180 minus 107.26 minus 64. And so our angle C is going to be 8.74. And that second angle is usually going to be pretty extreme because you are trying to make an obtuse triangle into an acute triangle with the same length. And so that's going to equal sine of 8.74, which will be over C, making our C value, let's see, sine of 8.74 times 16 divided by sine of 64. So our C value is going to be 2.70. And so again, the answers for the next piece is that the measure of angle C is 8.74. Measure of angle B in the next one is 107.26. And the length of side C is 2.70. So you've got those two cases. Alright, and then we get to do the same thing for the next one, only now they're giving us a C instead of an A proportion, so it's just sine of 68 over 18. Set that up with the same proportion. Looks like we are looking for A this time. And so I need to cross multiply, oops, not that one, cross multiply these, divide by 18 to get an angle A initially of sine of 68 times 19 divided by 18. Oh, and then the sine inverse of that, because that's not a degree. An angle A of 78.15. But of course the alternate to angle A is going to be 180 minus 78.15. So angle A now is going to be minus 78.15 is 101.85. And then we have our two cases. So we can continue with this first one here to get sine, oh sorry, we want angle C, oh, angle B. Oh, it looks like I'm going to have to continue on the next slide. Boo. Well, I'll do this one quickly. So we see we have angle B is 33.85. Then we set up our proportion as before to find side B. So we get, from solving proportionally, 4.65, angle B and angle A. And then the other one, subtract, gets 10.15. Set up your proportion with the new angle measure of 10.15 and solve proportionally for B. And so our alternate triangle has a B length of 3.42 and then our B angle and our A.